In this video, I'm going to use JavaScript to populate an originally empty SVG element and make a trefoil design. So here it is. So I looked it up in the dictionary. I wasn't sure how to pronounce it, but it can be pronounced trefoil or trefoil. And in addition, I've seen places where it says that the British put the F in the first syllable. So there are a number of pronunciations. I think I'm going to say trefoil. And it is this sort of three-leaf or sub-leaf sort of clovery design. And so I'm going to create it. I'm going to work through this link here shows sort of a compass construction, sort of like if I had a straight edge and a compass, how I could generate this design. So I'm going to use the idea in JavaScript of a generator function. And in a generator function, you call a function, but you don't execute the entire function. You execute the function up to some yield point. And so I'm going to do that to sort of, in my first SVG, to step through the compass construction of the trefoil design, and then play a little bit at the end with some multiple trefoil designs. So let's just step through it and see the compass construction. So I start off with a vertical line. I draw a circle on that line. So get out a compass, pick some initial radius, pick a point on your line, draw a circle. Take that with that same setting, draw another circle, this time with the center where this original circle crossed the vertical line, and make another circle and mark out the sort of 2 points where that crosses. And then take those 2 points where it crosses and the other line where the original circle met the vertical line, and connect those, and that with your straight edge, and that makes an equilateral triangle. And then from those points that were on where the two circles intersected, make a line again with your straight edge through the original origin of the original circle, and you're making lines that are sort of bisecting those angles of the equilateral triangle, and they cross at the original center of the circle. And then you could think of the vertical line as sort of a third one of these lines. And then you mark the points where those lines cross the equilateral triangle. And those are going to be the centers of the circles that make the trefoil design. So the trefoil design was this sort of three parts of a circle. And we've just sort of found the centers of those three circles, those sort of green points. So the next thing you do is you reset your compass. So you measure from that green point is now the center of a new circle. Here was the center of your original circle. And you measure out that distance on your compass, make that your new setting. And then you draw 3 circles. I have them as sort of purple dashed around each of those 3 points. Okay. And then we're almost done. Find those points where those circles intersect. They also intersect at the original center, but the sort of the new point at which they intersect. And then those points, that sort of circle you already have, beginning and ending at those points that you just found, that is the trefoil. So there's the trefoil design, that outer arc of that circle to those points where those circles intersect. So that's the completion of the sort of compass construction of the trefoil design. And now here is sort of multiple trefoils with different radii. So there are sort of two there's an overall radius of the center of the design, and then there are these 3 radii. So if I just change the radius of the sort of overall design, this is the sort of thing I get of, but this distance between these arcs is bigger than it is, say, here closer to this sort of vertex of the design. And then going back to uh, what was on Wikipedia, they have 2 trefoils where it's more, I don't know, equidistant or parallel, if you will. And so I will show in code sort of. So I also made the design to get that, and then you have to work with. I work to get this spacing here. I work with the center of the first circle, and then I had to do a little bit of algebra to find the distance to these other circles. So you'll see a square root with some deltas in there, and that's what I was doing there, is finding the distance, finding these points using the overall center, and then finding the distance to the 3 individual centers, and then that kept this more equidistant. Okay. So let's just look at a bit of code. I have, as I usually do in these, I use some style to define a size. I have a button, some text, a header, some text. Here are the 3 SVGs, which are all empty. This was a place for me to put my description of what I was doing while I was making the compass construction. This is a place where I'm getting some of my SVG language to use within JavaScript. This is me getting from the style, that variable, and I have a radius based on that size. And I work a lot with pi, so instead of getting math pi over and over again, I just said math.pi and called it pi. Now the angles that end up appearing all over the place here are sort of pi on 6 are 30-degree angles, and I'm using the trigonometry, the sine and the cosine of those, but I'm leaving it as sines and cosines for you to see, to sort of see the geometry, the trigonometry in there. But it could be the numerical work of this could be simplified just by putting explicitly in those sines and cosines rather than calling those functions. But I like to see the trig, so I left it. Okay. The button calls add to SVG, so that is add to SVG is just a normal function, but that normal function is using this generator object, and this generator object is calling this add to function, but it's not a regular function. You can see that by this asterisk here. It is a generator function, and the generator function is what allowed me to sort of step through the compass construction. So a generator function in JavaScript gets executed up to a yield point, and then but it also remembers where it was. So then when you sort of call a function again by the user clicking the button again, then you move from one yield to the next yield. And so this add to is just working through the compass construction, and I'm creating the SVG element and then adding it. So this was the code for the original vertical line. Then this was the original circle. Then this was the second circle and the 2 intersecting points. And then here were the 3 lines, the equilateral triangle. So I'm making a line, and it has an x1, y1, x2, y2, and there were 3 of them. So that is the equilateral triangle. Then I make lines that go from the vertices of the equilateral triangle through the origin of the original circle to the point where it meets on the opposite side of the circle. So that is the sort of the bisector lines. And then I find my points where the bisectors cross the equilateral triangles, the opposite sides of the equilateral triangles, and those are the three centers of the leaflets of the circles, and sort of constructing the three lobes or what have you. Then I am making circles around that go through the origin of the first circle and around those points that we just mapped out. And I made those purple, so I made 3 circles. Then I found the points where those circles overlapped. So here I'm marking a circle, but it's a very small circle with a radius of 5. So that's a point basically. And so I find the points where my circles intersect. And then finally, I'm at the end of my add to function, generator function. And this is the last step. And I'm just making the path of arcs that is the fine. So this is finally the trefoil. Where do I start? I'm starting down here. I have this middle point is MM. M was sort of half the size of my SVG. And so I'm starting at an X of M and a positive Y. Remember, positive Y when you're generating designs, visual designs in computers, the down is the positive Y direction. So I'm starting here at this purple point on the original axis. And so that's where I'm starting. And then I have, this is math. I'm making an arc. The A is for arc. The arc in general has, in SVG, is an ellipse, and so it has 2 radii. But I'm doing circle, so it has the same radii, but I still have to produce the parameter twice. And basically, it's math sine of pi, which is really just sort of half the radius. So the radii of the smaller circles are half the radius of the sort of larger circle. And then these are the points I'm going to. So I'm going, this was a negative X and Y. So I'm going from here up to that point and then around. So I have 3 arcs. So there's my starting point. There are my 3 arcs. My ending point is the same as my starting point. So I'm closing. And I have some parameters that go along with drawing arcs. The first one is the sort of a rotation of the arc. But since I have circular arcs, the rotation is irrelevant. So I just chose 0. And then there are these questions of, do I want, when I sort of specify 2 points in a radius, do I want a small little arc? Do I want an arc that's sort of less than the semicircle or more than a semicircle, and so on? And that's what these two parameters tell us, things like that. So it was for all of them 1 and 1. Okay, and then I make the path. So all of that is what's called the D parameter of the path. Then I make the path and I give it that D parameter and add it to my trefoil. Okay. So now down here, I'm doing the same thing. This is these designs below. And these are in the script, but not in any function, so they get made right away. Whereas the compass construction, if I refresh the page, requires all these clicks. But these designs below are just like there from the start. They're not in functions, they're just in the script, so they're called immediately. And so I'm just repeating what I had above, and then changing the radius by 1.1, I decided, and made it again. And then I changed it to 1.2 and made it again. And that gave this one, this sort of radiating trefoil, if you will. But then down here, this is now the last one where these are more sort of equidistant. And so this is just the very first original trefoil, so that was easy. The delta up here I had I changed the radius to 1.1. So the delta now is the 0.1 down here. And I did some algebra, trigonometry, what have you, to figure out what I have. Let me do it up here. I want to find the distance. So these green points are the centers of these circles, and I want now to move. Let me do one more. Okay, so I'm going to change the purple point, but to be along this line here. But then I want to find the distance from this green point. I don't want to change the green point. I want to keep its center where it is. But I want to measure its distance to sort of a pushed out point. So if I had a delta to move this point out, what is the distance from the green circle? I'm not changing it. I'm keeping it where it is. So I want them to be concentric circles. What's that distance? And so I did some of the work, and this is what I found. The new radius is r on 2 times the square root of 1 plus delta squared. Okay, so then so I'm doing 1 plus delta times r. So for the points in the arcs, here are the points where the arcs begin and end have 1 plus delta, but the radii of the actual arcs, so it is this r prime, which ends up to be the square root of 1 plus delta squared. So that is just a little bit of the math of having a sort of single radius and changing it versus sort of having a distance from the overall center and then finding the new distance to one of the trefoil centers, but keeping them fixed. And so that gave me these concentric circles rather than these sort of more, I don't know, radiating, moving centers that came here. All right, that's what I wanted to show you on this one. Thanks for your attention.